Help, guys! I'm in trouble. My system, it's become too high performance. I'm just joking. Okay, so I should probably select interpreter. All right, so I'll just fire this up, show you the situation. This is pretty much where we were before. Now have a look. There we go. Have a look at the frame rate. It's about what, 200, 300 frames per second. We can improve this. I mean, all we're doing is drawing blocks. We should absolutely be able to do this better. And there's a very good reason that the performance isn't so good. Just close this down and have a look at the render loop, the render function. Here we go. Okay, so render, we set everything up. We draw the sky. Okay, that's fine. Then we go to draw the ground. Okay, fair enough. Then we have this loop here. So we're looking through the list of blocks in the scene, and we are setting a color for each of them. We're setting a model transform. We're doing an individual draw call, and that's on top of the fact that we're calling a loop in Python, which is, it's slow. I mean, it's not that bad. All things considered, 200 frames per second is pretty good given the CPU load that we're doing here. But, I mean, it's all this for things that don't change. Sure, the colors of the blocks are changing, but that's not going to be there in the final game anyway. So the topic of this session is, let's, instead of looping through this, let's loop through once at the beginning, bake all of the geometry stuff into a single model, and then draw that one model. Okay, so just going to make a new file, which I'll call static geometry. Okay, now this is going to be based on the this class, this one here, the cube map, just as a template to start things off. Of course, we'll import everything from our config package. So we have all the OpenGL functions and everything, and then we can start working here. Okay, so the initializer really doesn't need anything. And what we can do is just get rid of all of this. So just pretend that that's done. Then we'll have another function which takes a list in XYZ form and appends it to the whole set. So we've got this. Then this code down here where we go ahead, send the data over, create the VAOs, VBOs and stuff. I'll call this finalize. Okay, and that is fine, I guess. Might be a good idea to cast this to an integer just in case. Should be fine. And now we'll deal with consuming. Okay, so we're going to take two arguments. We're going to take a whole set of XYZ points, and then we're also going to take a transform that we want to apply to those points. We'll apply the transform to the points, and then we'll take the results and send them to this vertices array. So the first thing I need to do is to reshape this array into XYZ1 coordinates. So if we imagine, I'll just write this out. We imagine we get a whole set of points. This is point 1. What I want to do is reshape it so that it is an array of arrays which are in 4 dimensions with a 1 on the end. Something like that. So the way I'll do this is, first of all, I'll measure how many vertices have been sent over. Okay. And then I'll make a just a flat array which will have all ones. And that gives me that fourth one on the end. So I'll call this raw vertices. And for the length, we'll take the vertex count times 4. So then I'm going to loop through and I'm going to overwrite a bunch of entries, but the fourth entry in each period of 4 is going to not be overwritten. That'll leave that 1 on the end. So let's do that now. So the raw vertices will have a stride of 4, which is why I'm multiplying by 4, stepping 4 across each time. But we're not overwriting everything. Whereas the vertices here will be x, y, z. They'll have a stride of 3. So we'll step across by 3 each time. Now, by the time we do this, we will have almost what we want. We'll have everything but just flattened out into one single array. And we can reshape it. So we'll go numpy reshape. I'm going to reshape that set raw vertices. The shape that we want is each row will be a new vertex, and then each column will be a component within that. So we'll have vertex count will be the number of rows, and I want 4-dimensional points. So 4. And that will get me this result. I need it in that form because then I can transform it. So I can go raw vertices, appear matrix, multiply, and then I'll send in raw vertices as the set to be multiplied, and that model transform is the matrix which will be in there, will be transforming them. And yeah, that will jump into the back end, multiply this, and we'll get all of these points will then become transformed. So then what I want to do is I want to go backwards. So I want to read out the transformed vertices and flatten them back into the positions. Okay, so yeah, I want to append onto my vertices array. I'm going to get the ith vertex from this set, so that'll be one of these, but then from that I want to slice everything from position 0 up to but not including position 3. And that's it. We've got that all set up. So by the time we call this function a bunch of times, we'll be remembering a bunch of positions, and yeah, the rest of that should be fine. Okay, so what I will do is I'll just create a static class by instantiating it once in the module, and then we can access that from other modules. Okay, cool. So let's go back to the view and close down a lot of this. Okay, so import that, and then we'll grab the class. Okay, so we have access to that, and I'm going to make a new function down here. Yep, just under create assets, because it will come after that, is and I'll also just import the model class, just so that I have access to those class definitions. Okay, so I have a list of blocks, and we'll also no, I'll get to that later. Okay, so we want to consume each of them. The set of vertices we want to consume is, if we go, what is it? Block debug model vertices. That's the array that we're after. And then the model transform is stored in the block Okay, so after we've done that, we can finalize that, and then we can destroy the block. We're just using it in read-only mode to set this up. Okay, so then we can just go down, and it's the usual sort of keeping track of things. Let's, yeah, whoops. Oh, it's not there. Okay, that's fine. I was going to say the block debug model isn't there. That's all right. Okay, so that should be fine. Now, if we go to the render, this is pretty nasty, pretty hard to read. Let's just do this. Let's say set the color. Let's get rid of that. And then for the model transform, well, the model transform has already been handled, so we can just set in the identity. That's fine. So we'll be using the big lumped model. Just double checking all of that. I think that's fine. Okay. So now we can go to the app. And then after we've created the scene, we can use it. So we can tell the renderer to bake the geometry. Then for the blocks, we'll go look at the scene, grab the blocks. Let's give that a shot, see how that's going. Okay, so that's running. Now remember, we had about 97 frames per second. Now we're running at about, it's in the 400s, and we can, I think we just move a bit and we go into the thousands. As it should be, because why bother looping through all of these blocks when they don't change, when they don't move? I mean, I want to paint this like I'm doing a good thing, but it's a really obvious thing, I guess. But maybe it's non-trivial. I remember when I was programming for the first time, I ran into this issue. It is a little harder to see the blocks, but later on they'll have textures and things that'll stand out. Now, another thing we can do is, of course, take it one step further. This ground should also not be a separate model. That should be part of the static geometry as well. Heck, it's the same color. So that's actually not too hard to do. What we can do is just go to the view class, the view module, and then in the object model, we're almost there. What I want to do is make a copy of, make another array which doesn't just have all the data together, but it just has the position data. So it's not too hard to do. I'll just go ahead, get the vertex count, and then I'll make an array called positions. And it doesn't matter what I fill this with, I'm going to fill it with zeros. There we have it. And then we can just loop through. So we'll go for I. So as you can see here, the vertices set has a whole bunch of things written to it. It has a stride of 8, but we just grab the first 3 of each bundle and throw that in there. So that is fine. We should now be able to use any of these models either individually or consume them to the lump and then run the lump. So I'm going to modify this bake geometry so that we also take a ground instance. And I'll go back here and we'll also pass in self scene ground. There we go. Okay. All right, so we'll go self ground debug model. We'll throw in there. But not that, is it? We need the positions there. Okay, and then the ground has a model transform which you can pass in, and then finally we can destroy the ground debug model. We've used it, don't need it anymore. And right down the end, we do not need to destroy it. We've already destroyed it. Okay, and then up the top. See, this is another reason I'm doing this, is this stuff is getting so hard to read. Okay, so we can just get rid of all this. This is the ground quad. We don't need it. That's being handled. Okay, so fingers crossed, let's give that a shot. Haha, what have I missed? Oh, okay. I see what I've done. I forgot the slice, the colon. So it should be 3i up to 3i plus 1. Not a plus. Okay. There we go. So now we have everything just like before. Maybe not a big deal, but at least the system's working. Okay, so I'm pretty happy with that. It seems to be working well. Yeah, okay. That's fine. All right, so hope you enjoyed that, and I'll see you again soon. Have a good one. Bye.